All right, in lesson 1, we talked about turning repeating decimals to fractions using the algebraic method. So the algebraic method works with all repeating decimals, but more importantly, we need to use it when there's more than just a repeating number comes after a decimal. Like in this example, we have a 2 that's not repeating, and then we have our repeating numbers. So we need to use the algebraic method. Our first step is to set x equal to that decimal, showing at least one of the repeating digits. So 1.24, where the 4 is repeating. Your second step then is to either multiply by 10 or by 100. This is based off of how many repeating digits there are. So we have one repeating digit, which is 4. So we're only going to multiply both sides by 10. So we get 10x equals 12.4 repeating. Then the third step is to subtract. And we're going to subtract both sides by x. But remember that x is actually equal to 1.24. So when we subtract these, 10x minus 1x is 9x. And on the right side, before I can subtract, I notice I'm missing a digit above this 4. So I need to add another repeating 4. Now 4 minus 4 is 0, and 12.4 minus 1.2 is 11.2. The fourth step is to divide. And we're going to be dividing by 9 or 99, depending on what we multiplied by in step 2. Here we're dividing both sides by 9. I'm going to show you this without a calculator first. So without a calculator, we get x equals 11.2 over 9. If I multiply both the numerator and denominator by 10, I can clear that decimal in the numerator with 112 over 90. Then I can go ahead and write this as a mixed number. 90 goes into 112 one time. 90 times 1 is 90, so I have 22 left over. And then that simplifies to 1 and 11/45. If you used your calculator for step 4, in your calculator you would type in 11.2 divided by 9 equals, then second PRB equals, and that would give you 1 and 11/45. So you can do that as well. So there's the algebraic method that we've been working through in lesson 1.1. There is another way that you can do this, which our book does not talk about, but I at least wanted to show you so you can feel free to use it if you're comfortable with it, or you don't have to. So the 9 trick. The 9 trick doesn't work with all repeating decimals. It only works when the repeating digits come after the decimal. So it has to be only repeating numbers after the decimal and nothing else. So in example 1, the repeating number after the decimal is 2. We have 0.2 repeating. So I'm going to draw my fraction bar, and the numerator is the repeating digit. So my repeating digit is 2. My denominator is going to be 9s, and the number of 9s is equal to the number of repeating digits. I have one repeating digit, it's 2, so I'm going to write 1 9 in the denominator. This fraction 2 9s cannot be simplified, so that means 0.2 repeating is the same as 2 9s. Let's look at example 2. In example 2, what are the repeating numbers? 18, good. So we're going to take the whole number 2, and then our repeating piece goes in the fraction. The 18 is repeating, so that's my numerator. 2 digits are repeating, 1 and 8, so I need a 9 for each of those. So we put 2 9s. So my fraction is 2 and 18 over 99. That can be simplified. 18 and 9 are both divisible by 9. So we get 2 and 2 11ths.